Have you ever been stuck doing long division, just thinking, there has to be a faster way? Well, there is. Today, we're going to unlock the mental shortcuts that make math feel less like a chore and more like a superpower. Okay, let's dive in.
So, take a look at this number. Your first instinct is probably to reach for a calculator, right? Or maybe a pencil and paper to start grinding it out. It looks like a lot of work, a real pain, especially if you're on the clock during a test.
And there it is. The answer is a clean, simple yes. No remainder, no fuss, it divides perfectly. But, the real question isn't what the answer is, it's how in the world you could know that so fast.
And that's the secret. You don't actually have to do the division. Stick with me, and by the end of this, you'll be able to look at a number just like that one and get the answer in seconds. Ready to learn how?
All right, let's start with the easiest tricks of all. These are the ones where you only have to look at the very last digit of a number. Think of these as the low-hanging fruit.
First up, the rule for 2, and you probably already know this one. You're just checking if the number is even. In other words, does it end in a 0, 2, 4, 6, or 8? So a number like 240, that 0 at the end is an instant yes. A number like 135, that 5 makes it an instant no. It's that simple.
And the rule for 5 is just as easy. You just glance at that final digit. If it's a 0 or a 5, the whole number is divisible by 5. So 430 ends in a 0, that's a yes. 128 ends in an 8, so that's a definite no. Easy. And the easiest of them all, the rule for 10. If a number ends in a 0, it's divisible by 10. That's it. That's the whole trick. Okay, so those are the absolute basics. But what happens when the last digit doesn't give you the answer? Well, this is where things get really clever.
Now for a really awesome technique. We're going to stop looking at just the last digit and start looking inside the number itself. This is the key to cracking 3 and 9.
Okay, so here's the big idea for testing divisibility by 3. You don't care about the number as a whole. Instead, you just look at what its individual digits add up to. If that sum is a multiple of 3, then the original number is 2.
Let's try it out with 2, 3, 4. We just add the digits. 2 plus 3 plus 4 gives us 9. And we all know 9 is divisible by 3, right? Well, that means 2, 3, 4 is also divisible by 3. No long division needed at all.
And here's where it gets really cool. Once you master that digit sum trick for the number 3, you've basically already learned the rule for its more powerful cousin, the number 9. It's the exact same method. You add up all the digits of your number, but this time, you just check if that sum is divisible by 9. If it is, the whole number is. Same trick, just a higher standard.
So you can see how they're a pair, right? Both rules use the exact same process. Just add the digits. The only difference is that final check. For 3, you ask, is the sum divisible by 3? For 9, you ask, is it divisible by 9? If you think of them together, they're super easy to remember.
Okay, now we get to see how these simple rules can actually be combined and expanded. We're going to build on what we already know to create tests for even more numbers. This is where it gets really interesting. So, what about the number 6? Well, there isn't a unique one-step trick for this one. Instead, we use a clever combination of 2 rules we've already covered. Any guesses which 2? To be divisible by 6, a number has to pass 2 checks. First, it's got to be an even number, so it has to pass the test for 2. And second, its digits have to add up to a multiple of 3, so it has to pass the test for 3. If it passes both of those, it's divisible by 6.
Now let's look at a new pattern, checking small groups of digits. For the number 4, you can pretty much ignore the whole number. Just focus on the last 2 digits. If that little 2-digit number is divisible by 4, the whole thing is. So for 524, we just look at the 24. Since 24 is divisible by 4, we're done. And the rule for 8? It's just a bigger version of the rule for 4. Instead of the last 2 digits, we look at the last 3. So in 5128, all we have to do is check if 128 is divisible by 8, which it is. And this takes us right back to our very first question. That's how we knew 4,821,576 was divisible by 8. We only had to check the 576. Pretty cool, right?
All right, time for the grand finale. The rules for 7 and 11 are a little different. They're a bit more involved, but honestly, they are incredibly elegant. These are the pro-level shortcuts that'll really make you feel like a math whiz.
Okay, the test for 11's kind of like a rhythmic dance. You add up alternating digits. So here, with 2,343, we take the first and third digits. That's 2 and 4 and get 6. Then we take the second and fourth digits, 3 and 3, and also get 6. Subtract those two sums. If your result is 0 or any other multiple of 11, the number is divisible.
And now for the famous or infamous rule for 7. It's this neat little process. You take the last digit, in this case, a 3. You double it, which gives you 6. Then you subtract that 6 from the rest of the number, which is 20. That leaves you with 14. Since 14 is divisible by 7, our original number, 203, is 2.
So, why even learn all of this? It's simple, really. These aren't just party tricks, they're seriously powerful tools. In any situation where time matters, like an exam, they let you solve problems faster and with way fewer chances for error. It's all about working smarter, not harder.
And that is the key takeaway. You're now equipped with a totally new way of looking at numbers. That big, intimidating number is no longer a long division problem waiting to happen. It's a puzzle you can solve in seconds, just by applying these simple tests.
It really makes you wonder, doesn't it? Math is just filled with these beautiful, hidden patterns. And if rules this simple can tame huge, complex numbers, what other elegant secrets are just out there, hiding in plain sight, waiting for us to find them?